Right, good evening, ladies and gentlemen. We are wrapping up our study of Chapter 3 today. We're going to be looking at the mathematics of finance, which is going to go into our exponential equations still. And we'll be using our exponentials and our logarithmics and that sort of stuff to solve some equations. We're going to be basing all of today off of 5 formulas, 3 of which we should be familiar with and 2 of which are brand new to us. So let's go ahead and get started at looking at a very simple formula. This is called simple interest as well as just this basic formula that we're going to get here. We've been doing this formula basically since Algebra 1, so we might be familiar with this. This is compounding annually, and we get this very simple formula here. And what this is P is equal to my principal. R is rate, and this is as a decimal. This is kind of should be obvious. And N is number of years. Okay, so we can look at if we put some money in, that's my principal. If I put money into an account, and I was getting a certain percentage rate, I could see how much money I would have at the end of in number of years, 50 years, 100 years, that sort of idea. What would I have in there? So I have an example here. Let's say you invested $500 at a 7% interest rate compounded annually, and I want to figure out you want to figure out how much you would have in your bank account 10 years later. Now, this is a very simple formula. That's why I said we call it simple interest. It's not necessarily how the real world works, but this is kind of one of the first things we look at when we look at interest rates. Now, I kind of looked through my word problem because that's kind of what it is, and I noticed there are 3 numbers, and that's usually the first thing I look at, and the fact that we're looking at annually. Okay, this equation only works when it's compounded annually. All right, so P represents the amount of money I put in, which means that's my 500. So I look at this equation, I go, okay, P is 500. Please don't put dollar signs in your equations. That is way below us now. We don't do that anymore, ever, okay? I know my R value. My R is my rate, and this is as a decimal. So 7% is the same thing as 0.07. And N is the number of years we are having our investment in there. And in this case, it's 10 years. Okay, so that means we're actually trying to solve for A. And this just ends up being a simple plug in the calculator problem. So if you plug this into your calculator, you get 983.5756 Now, that number really doesn't make sense in the real world, even though technically banks will use this type of decimal. When we think about what your bank statement is going to say, your bank statement will probably say $983.58. Even though the bank might actually write out 0.57, just because that's the way banks work sometimes. They don't actually round up all the time. All right. So in this very simple equation, we have put in $500 at 7%, and after 10 years, you should have $983 in your bank account. Okay. That's not great. I mean, you put $500 in and you didn't even get $500 out after 10 years, but it's a start. Okay. What we want to do is we want to look at a slightly different type of equation and slightly different type of compounding. So the next formula is also one that we've used before, and this is compounding K times per year. And the formula is almost exactly the same. P still represents the principal. R still represents the rate. T is going to represent time, the number of years, basically. And what K represents, K is number of times compounded per year. So if I told you it compounded monthly, K would equal 12. If I told you K compounded quarterly, then it would equal 4, once every quarter of the year. If I said it compounded every 3 months, that's the same idea, right? Because there's 4 groups of 3 months in a year. If I told you it compounded every 4 months, then K would equal 3, because that's how many times 4 goes into 12, right? Okay, so what I want to look at is basically the same problem, only this time I want to see how much money you have in your investment 10 years later if the problem said compounded monthly. I'm going to use kind of the same numbers for the first couple examples here. So notice it says compounded monthly, so I can't use the equation from before. I can't use the yearly formula. And I look at my important pieces. Okay, so I'm investing $500 at 7% compounded monthly, which means K equals 12, because there's 12 months in a year, right? You know that, duh. Okay, so K is 12, and then we get 12 times the number of years, so it's 10. And if you think about this number here, we're looking at how many times it's compounding in 10 years. There's going to be 120 different compounds throughout this 10-year period. So that's what this 12 times 10 comes from. All right, and again, this just becomes some calculator work here. And if we kind of did our calculator, if you give me a second, I'll plug this in. Hopefully you're plugging this in at the same time, kind of figuring out how this is going to work. So 500 times 1 plus 0.07 divided by 12 to the power of 120. You can do 12 times 10 if you want, but I hope you know what 12 times 10 is. And I get, oh, look at that. Now you get 1,004.83, oops, I missed, 8306. 88. And again, real world, that doesn't make sense. So A here is going to equal, the amount in your account is $1,004.83. All right. Well, that's kind of cool to me, is if you change the number of times you compound it per year, you actually get more money, which really starts leading into more of the real type of compounds that actually happen. They're compounding real world things. So this is getting closer. Sometimes you might find this in little areas like investing into mutual funds or that sort of idea. But bank accounts usually follow a slightly different formula. I'm going to actually look at a different example before I get to that other formula. And what I want to know is a slightly different question. And these are the questions that lead us back into what we just learned on the previous lessons, the 3.4 and 3.5, actually more 3.5. And what I'm saying is, now if you invested $500 at 9% interest compounded monthly, how long will it take your investments to grow to $3,000? So you can kind of use your formula from before to figure out the amount of time it's going to take to get to a certain thing. So we are going to use the A equals P times 1 plus R over K, all to the KT power, because this is compounded monthly. And if you think about this, this formula actually is the same thing for yearly. I mean, K would just be 1 because it's compounded 1 time per year. Okay, I forgot to mention that a minute ago. All right, so in this case, my A is the amount in my account. Well, that's the $3,000. I have $3,000, or actually I want $3,000, and I've invested $500 at 1 plus the rate of 0.09 this time. I use 9% instead of 7. I don't know why, but I did. Compounded monthly, so 12 times. So this time it's 12 times t. Now notice where t is. We're solving for time, so we're going to have to do this is an exponential, so we might have to do a logarithm. Okay, so bear with us here as we do this. We're going to divide both sides by 500. 3,000 divided by 500 is 6. And we get 1 plus 0.09 over 12 to the 12t. Now, you might be struggling here and trying to figure out, how do I get rid of this thing so I can get the exponent by itself? Well, through our laws of logarithms, we recall if we take the log of both sides, we can cancel out the exponential. Well, when I take the log of both sides, so if I just had 6 equals 2 to the x, if I took log of both sides, log of 6 equals log of 2 to the x, this becomes log of 6 equals x log of 2. And you notice that this just ends up being that the exponent is equal to log of the one side. Oops, I don't even know where the g came from. Log of 6 divided by log of 2. That's a simple problem, but it helps us here because this is like our 6, and this here is like our 2. So you notice I can actually kind of simplify the process here, and I can say that 12t is equal to the log of 6 over the log of 1 plus 0.09 over 12. And then if I wanted to plug everything into the calculator at the same time, I can divide both sides by 12, and I can get t equals log of 6 over, dividing by 12 is going to put the 12 in the denominator, by the way, 12 log of 1 plus 0.09 over 12. And what you'll notice here is I have not plugged anything into my calculator yet. And it's kind of handy because that means you haven't done any rounding yet either. So now you have stuff you can plug into your calculator. Do it, see if you can get the right answer, see what you get the same as answer as me, and let's kind of see what we get here. So log 6 divided by 12. Be careful here because put the denominator into parentheses or you're going to get the wrong answer. So 12 log of 1 plus 0.09 divided by 12. And I get 19.98300,222, which means it's 19.98 years. It's going to take you 20 years to get $3,000. All right, so that's kind of a long time. Some of you guys, none of you guys are 20 years old yet, so, that seems like a really long time to you. Don't worry, after a while, 20 years is going to seem like nothing. All right, so that's a how long type of question. We could ask all sorts of things as well. If I just wanted to say, if I said basically the same exact thing, and I gave you 20 years, and you needed to figure out how much interest rate. And notice I could just ask the different types of questions. I could say, well, how many times was it compounded given certain information? Or what was my percentage rate given the other information? If you look up here, the equation has 1, 2, 3, 4, 5 variables. So if I gave you 4 of them, you could always solve for the 5th. All right, so that's kind of how the equations go. That's actually, notice my 4 underlines here. This was my A, my P, my R, and my K right here. So we solve for T. And that's how all equations go. All formulas go that way. If you're given 3 of them, 3 variables, if you have 2, you can solve for the 3rd. All right, that's pretty basic. All right, now into this other one. This one, some of you guys think this is the only equation. And this is compounded continuously. This is called a PERT. And that's just how I call it because that's what it looks like. If you read it across from left to right, it's a PERT. And E, I hope you guys all know, E is Euler's number. It's the 2.718. And that's the one on your calculator. And the R is the rate, the T is the time in years, and P is still principal. Now, this seems like a very, very simple formula, and it is, but it's actually more real world oriented because that's kind of how bank accounts work. They compound continuously. All right, so same question as before, only this time it's compounded continuously. All right, 7%, $500, 10 years. Same question, only this case we're going to use APERT because it says compounded continuously. Very key here. So I want to know how much money we have. And I'm going to say, okay, 500e to the 0.07. Notice it's not 1 plus the rate this time. It's not 1 plus. It's just the rate itself. And again, this becomes a very simple plug into the calculator problem. And you do that, and you get 500 times e to the 0.07 times 10. So it's actually 0.7, right? And I get 1,006. Now, that doesn't seem like it's much of a difference as the previous problem, where it was $1,004. Okay, so I got 1,006.88, so that's how much I would have in my account. But it does actually make a difference with bigger investments. Bigger investments, $2 really could end up being like $20,000 difference if you had invested more money. All right, this is a pretty easy, all three of these formulas I think are very easy to use and something that should be familiar to you. All right, so let's get into the other types of equations. These are really real-world bound problems. Okay, I'm going to skip that. And one of them here is the future value of annuity. This would be something along the lines of this. What if we wanted to add money to our investment over time? Because usually you don't just add $500 at the beginning and then just wait for it to grow. Usually when you are growing up, and parents used to do this all the time, or my parents even did, you say, okay, let's put $10 into the bank account and let's do it every month. And we could see, okay, yeah, you're putting $10 in and then your money's going to go up over time. And let's see what this kind of looks like here. Because this is more real world. This is what we look at. So FV is future value. R, actually I think I have this written here. R is the periodic payment. So how much you're putting in periodically. So I could be adding $50 at the end of each month or $500 at the end of each quarter. And this actually is how things work. This is how my paycheck works. Or actually, this is how my paycheck works. I put in money into my retirement fund every month, and my retirement fund grows with a certain percentage rate. And your parents might be doing this with, you might have heard of a 401k, right? You put money into an account, your 401k, your retirement account, and you put money in every month or twice every month, actually, because most people get paid twice a month, okay? And it kind of grows at a different style than just the compounded monthly or compounded annually. All right, so long story short here, R is the periodic payment. I is my rate divided by number of times compounded. So K is like before. So K is the number of times being compounded. And N is also K times T. So it's the same thing as before. K is the number of times compounded, and T is my time in years. So you notice we use I in two different spots here. So we're going to need I. All right, so you're going to need this stuff coming up to this example. So let's say you put $500 into a mutual fund, which is basically an account that earns interest at the end of each quarter. If your investments earn 7.88% annual interest compounded quarterly, what will be the value of your annuity after 20 years? So we need some stuff. This is a lot more complex than the previous problems. So I need 500. That's my p value. Or sorry, not my p value. We don't use p in this equation. This is my r value. All right, 7.88. That's my little r value, but little r really is part of my I. All right, and we're compounding quarterly, and we're looking for 20 years later. So I is my rate over the number of times compounded per year, and it's quarterly, so it's 4. My n is k times t, so it's 20 years compounded 4 times per year, which is 80. My big R is what I said earlier, 500. And that's actually all I need to know. Notice the formula is not really that hard. It's just picking out the pieces that you need. So my future value is 500 times 1 plus I, and I'm going to use I in my calculator. I just want to write out the decimal here. To the 80th power plus 1, minus 1. All over that 0.0788 divided by 4. And again, it's just calculator problem. You should probably try to figure out how to plug this into your calculator. This one's a little bit more complex. If you're plugging this in one shot, make sure you put an extra parentheses around that. Maybe even try parentheses around that. It shouldn't make a big difference right there, but you might want to do that. So 1 plus 0.0788 divided by 4 to the 80th power minus 1 divided by 0.0788 divided by 4. And I get 95483.38932, which means my future value 20 years later is going to be 95,483, if I could draw a 3 apparently, and 39 cents. Hey, that's not too bad. It's not something you could retire on at the end of 20 years, but it's a start. All right, this is a very basic equation, very basic problem. Okay, so last one here is present value, and what present value is kind of saying is we're going to calculate loan payments actually in this particular case. Notice the equation's almost exactly the same. PV is present value. R is still the same as before. It's the amount you're paying. I is still that rate divided by the number of times. And N is the same kind of idea as before. All right. So here's your example. You purchase a new truck for 18. Oops, that was not supposed to be a percentage sign. Haha. That's supposed to be a dollar sign. $18,500. And I want to know what's your monthly payments for a 4-year loan with $2,000 down payment if the annual interest rate, or APR, as you may know those letters there, is 2.9%. All right. So some things that you need to know is how this equation works, obviously. So the truck costs $18,500, but you're putting $2,000 down, which means your present value is actually $16,500. You're borrowing this much money because you put $2,000 down already. Your R is actually the thing we're solving for because we want to know how much you're paying each month. My I is 0.029 divided by 4. And my N is equal to, not divided by 4, because it's not 4 years. Not paying attention to my own work here. Divided by 12. And my N is 4 times 12. Because we're looking at monthly, by the way, in case you were wondering where I got the 12 from. We're looking at monthly. And again, that's all I need to know. Now I just need to solve for R, so it makes it a little bit more challenging. So I get 16,500 equals R times 1 minus 1 plus 0.29. Whoa, what am I doing there? Divided by 12 to the power of negative 48 all over 0. Oh, that's what my problem is. 29 divided by 12. Man, my writing is getting ugly today. So this becomes, again, some challenging plugging into the calculator ideas, but it's not something we can't do. Notice that this is a fraction right here on the next to the R, which means I can multiply both sides by the reciprocal, which means R is going to equal 16,500 times 0.029 divided by 12, which is the denominator here, all over 1 minus 1 plus 0.029 divided by 12 to the negative 48. And look at that. Now it's just something we can plug into the calculator. There's not even any logarithms to deal with here, luckily for some of you. So 16,500 times 0.029 divided by 12 divided by 1 minus, again, pay attention. You do need parentheses around this whole thing here if you're plugging into your calculator. And I get 364.4876. And if we think about this, that means you're paying $364.48, actually 49 cents, every month. And if you really think about it, you're going to pay $364.49 for almost 4 years. And then right at the last month, you're going to pay just a little bit less because you're actually paying more than the actual R value. And that's all I have for us today. Our assignment is as listed. It's on your assignment sheet. You got to remember this is the last section for Chapter 3, so we have a test scheduled on Thursday. We'll do a little review on Wednesday. And yeah, so good luck with the math. Hopefully everything kind of goes well. I will see you guys Monday.